In this example, we are looking at multiplying two rational expressions. A rational expression is a fraction, or you could say a ratio, of two polynomials. In this case, we are going to be looking at polynomials that are monomials or just one term. Okay. In order to multiply rational expressions, we are actually going to factor all of the numerators and denominators before we begin. That way we can cancel common factors before we perform the multiplication. This is going to make it a little easier because we'll be multiplying smaller values and smaller binomials or monomials together. And it's also going to reduce the simplification needed at the end. In fact, if we do this correctly, we should not really have to simplify at the end. Now, you always want to check and just make sure that your fraction's in simplest form when you get done. Or, check the instructions and make sure that you are returning the value in the form that they would like it. So we're going to go ahead and get started. Our first step is going to be to factor. Now, you may factor each of your monomials completely into its prime components. I'm actually going to be a little more selective about how I do it, just because I think it's a little easier to maybe do it this way once you've seen it. So just try my method and see how it works for you. I know that 63, looking at what I've got. So let's just take a minute and look at what we've got first. I have 63x on top. I have a 9 downstairs, x to the 6th upstairs, and 7x squared down here. So first thing I'm thinking is, let's look at my numbers. I have 63, 9, and 7. I know 9 and 7 both are going to go into 63. So when I factor 63, I'm going to express it as 9 times 7. So if we can choose factors that we know will cancel with other factors, it'll make this process a little easier, I think. So for the 9 that was down there, and I'm not done with it, I'm going to leave the x. There's not really a lot you can do with x. So let's just put the x there as well before I move on. So we have 9 times 7 times x. Those are all upstairs. Those are all factors. Downstairs, this 9, I'm going to leave it because I know it's going to cancel. Now, if you wanted to express both of those as 3 times 3, that's perfectly fine as well. But I prefer to do it this way. Now, looking over, I'm actually going to look at these two kind of together just to help me make a decision. I want to break my x to the 6th power down. Now, I know that there's 2 x's down here. So I'm going to plan ahead a little bit just by looking and say, hey, I know I'm going to want to break 2 off. And then I know by my product rule, x to the 4th times x to the 2nd is going to give me x to the 6th. So I'm really expressing it as the factors that I need. If you would like to expand all 6, you may. It's just kind of a lot of work. And then last on the bottom, I'm going to keep my 7. 7's prime, but also 7 was one of my factors I chose for 63. And last, my x squared downstairs. I'm going to leave that alone because, again, I picked that to match. So our whole goal here is to try and identify like factors and cancel them before we begin. That way, when we get done, all we have to do is multiply across the top, multiply across the bottom, and we have our answer. And in theory, we've done it correctly. It's in simplest form. So let's see how it goes. I'm going to cancel, and I'm going to cancel each factor in a different color to try and help you see as I'm doing it. So I canceled the 2 9s, and you can cancel anything upstairs with anything downstairs. And so these 7s, it's different rational expressions, but they're both upstairs and downstairs. I'm planning to multiply these, so I know I'm okay to cancel it. Okay. And last, the other value that I can cancel is going to be this x squared with the x squared downstairs. Okay, so we've canceled. I'm going to go ahead and look at what I've got and just double check. I have an x remaining here, and you may want to go ahead and, as you're doing this, think about putting that x1 up there. If you're kind of new with dealing with exponents, so just remind you there is one of them, the exponents understood. We have an x to the 4th. Everything else pretty much been canceled. So when I'm looking at this, I'm going to multiply across the top my x to the 1 times x to the 4. You add exponents. That's the product rule from your exponents. So x to the 1 plus 4 is x to the 5th. Now downstairs, what happened? Well, when we've been canceling things, I think everybody kind of knows. Look at the 9 over 9. Really what we're doing is we're replacing them with the 1 because that's just equal to 1, right? So, and I don't write all those ones because it's ones all over the place and it kind of gets a little messy. But it's understood that if I cancel everything out, there's going to be a 1 remaining from the cancellation process. So downstairs, I have that 1. Now, x to the 5th over 1 is the same as just having x to the 5th. So I will simplify that before that's my final answer before I submit it or, box it in. And we are done.